Hello everyone, welcome to my YouTube channel. In today's video, we are going to learn to derive an expression for radius of curvature in the Cartesian form. So let us start this derivation. It's a very important derivation and it is usually asked for 5 marks in all the engineering exams in the first sem mathematics. So let us start this question. So first we'll draw the figure. So first we have to draw a xy plane. This is the x-axis and this is the y-axis. Now let us consider a curve in the xy plane. This is a curve and it is since it is a Cartesian equation, so the equation of this curve will be y is equal to f of x. So let a be a fixed point on it and let p of x comma y be any point on the curve, and the length of the arc AP is s. We have to consider this much. Now the angle that a tangent P will make with the x-axis will be psi. So let us make that. This is a tangent that is passing from the point P on the curve and it makes an angle psi with the positive x-axis. So this is the diagram. We will get almost 2 marks if we draw the diagram in these exams. So now next step what we have to do is we have to consider tan of psi. Tan psi is equal to dy by dx. We know that tan psi is dy by dx, which means this is a slope of the tangent. So now we have to differentiate this equation both sides with respect to x. So let us do that. When we differentiate it with respect to s on both sides, we get secant square psi d psi by ds when equal to d by ds of dy by dx. In the next step, we'll write secant square psi as it is, and this term we have to write it as 1 by rho. 1 by rho means like we know that radius of only the curvature is equal to d psi by ds, and the radius of curvature rho is given by ds by d psi. So here it is d psi by ds, so we'll write its reciprocal, that is 1 by rho. This is equal to this d by ds, we can write it as d by dx of dy by dx, and this term we can write it as dx by ds. It is similar as ds by d by ds. Now next term secant square psi 1 by rho will be as it is, and now we have to differentiate this d by dx with respect to dy by dx. We get a second order derivative, that is d square y by dx square, and d psi by ds will be written as cos psi. From the previous topics of derivative of arc length, we get this term. Next, now we have got this equation. Now let us write all these terms in terms of rho. So I'll write like this. Rho will become as secant square psi d square y by dx square will come this side and it will come in denominator, d square y by dx square, and cos psi will also come in the denominator, cos psi. So now when this cos psi will go up, it will become secant psi. Secant square psi into secant psi will become a secant cube. So this will become as secant cube psi divided by d square y by dx square. Now rho is equal to, I'll write secant cube as secant square psi whole raised to the power 3 by 2, which will be similar to secant cube psi, divided by d square y by dx square as it is, d square y by dx square as it is. Now let us write this in the next page. So in the previous step we got till here, that is rho is equal to secant square psi whole raised to the power 3 by 2 divided by d square y by dx square. So now we'll write secant square psi as 1 plus tan square psi whole raised to the power of 3 by 2 divided by d square y by dx square. So we started our derivation with by considering tan psi as dy by dx. So we'll replace this here Now we will get 1 plus tan square xi will become as d square dy by dx whole square, whole raised to the power 3 by 2 d square y by dx square. Now therefore rho, that is radius of curvature in Cartesian form, is 1 plus dy by dx can be written as y1, that is first derivative, whole square, whole raised to the power 3 by 2 divided by d square y by dx square can be written as y2. So this is our radius of curvature in the Cartesian form. Radius of curvature in Cartesian form, and it is usually asked in 5 marks for the exams. So it is a very important derivation, and you can easily score good marks if you practice it thoroughly. So if you like my video, please subscribe to the channel, and if you want more videos on such topics, please put it in the comment section. And thank you.